Assalamualaikum and hi. So today we're going to learn about motion along a straight line, part 1. So let's see what we're going to cover in these chapters. So basically in this chapter there are three subtopics. The first one will be displacement, which is sasaran. Second one will be velocity ataupun laju. And the third one will be acceleration, what we call it as pecutan. So you have sasaran, had laju, dan juga pecutan. Okay, but for today, we only going to cover, for the first part, we only going to cover displacement and the first half of the velocity. So, okay, let's see. This is the whole pictures about motion along a straight line about this chapter. So we have three major subtopics: displacement, sasaran, halaju, and also acceleration, pecutan. So for displacement, of course, you will have positive and negative and also zero displacement, as well as for velocity, you will have positive, negative, and also zero velocity. Same goes to acceleration. You have positive, negative, and zero acceleration. So we're going to see each of these positive, negative, and zero. What does it mean by all these three term of displacement and as well as for the velocity. And there is addition for displacement. We also going to see about total distance travel in the first and second. Maksudnya jumlah jarak dalam tempoh beberapa saat. Okay, and in this subtopic there will be motion diagram method, displacement time graph method, velocity time graph method. You will see all this as we go through these chapters. This chapter, okay, and then we will have distance travel during n second. Okay, so this one is total distance and this is only for a specific distance, which is the formula is given by this. Okay, so don't worry, we will see all the formula you have see over here. We're going to um, explore it and apply it in a problem, so we can see how you can use it later. Okay, so this is the first subtopic, which is displacement. Dalam bahasa Melayunya adalah sasaran. So a particle, let's see what does it mean by displacement. A particle which is moving in a straight line passes through a fixed point O. So we have one point O, okay? Point O ni yang asal dia. Tempat mula-mula dia particle tu berada. So its displacement, sasaran dia atau diwakili oleh small letter of s, huruf kecil s, from the point O at t seconds after passing through O is a function of time and is written as s equal to function of t. So apa yang dimaksudkan di sini adalah sasaran tu adalah kita boleh tulis sebagai satu function t. Okay, so small letter ni s ni adalah sasaran. So dia kita ungkapkan dalam sebutan fungsi t. Kenapa fungsi t? Sebab sasaran tu berlaku dalam t second. Beberapa second lah yang where t ni kita tidak tahu lagi what is the value. We still don't know what is the value for t. Okay. Okay, then second one, total distance travel in the first n seconds. Maksudnya jumlah jarak yang dia dah bergerak, yang kita dah travel in the first n second, for the first n second, saat yang n yang pertama in the total distance travel by the particle from time t equal to 0 to t equal to n. First and second maksudnya beberapa detik yang pertama. So maksudnya bermula daripada t kosong until t equal to n. Yang mana n ni we still don't know the value. It might be 5 second or 10 second or whatsoever lah kan. Okay, then distance ataupun jarak travel during the n second. Tempoh yang kedua pula. Yang tadi kan yang pertama, so yang pertama it will start from 0 until n. Then the second tempoh yang kedua pula, the formula is given by this. T equal to n minus 1 to t equal to n. Kalau tadi start daripada t equal to 0, now it will start from t equal to n minus 1 until n. Okay. Therefore, we can say that distance traveled during the n second is given by this Sn minus 1. Okay. So, S ni maksudnya, Sn ni maksudnya yang pertama. This one is yang, S ni adalah dia punya, ni, kita punya displacement tadi ya. So, we just follow this formula. Ini untuk yang n second. Detik yang kedua lah. Okay. Another thing that you need to know is about displacement. Where displacement is a vector quantity. Vector quantity tu apa maksud dia? So, vector quantity meaning that you have magnitude and direction. Dua-dua ada. Both magnitude and direction. So, if you see this diagram, let's say this is a point O. If you move the particle, this is the particle. Okay, yang bulat ni adalah particle dia. If you move the particle to the right hand side, ke sebelah kanan, the S or the displacement, sesaran tadi is positive. Why is it positive? Because you are moving towards the right hand side, bergerak ke kanan. And then bila you gerak ke kiri, it become negative. Sesaran tu akan jadi negative. And bila dia asal dekat sini, dekat point O ni tidak bergerak ke mana-mana, dia punya sesaran adalah 0. Okay? So remember, kalau dia bergerak ke kanan, you akan dapat value untuk sesaran tu or value untuk the displacement will be positive. If you get a negative value, meaning that the particle is moving towards left hand side, bergerak ke kiri. Okay. And bila you dapat S2 equal to 0, maksudnya dia belum bergerak lagi ataupun dia masih stay dekat situ. Okay, zero displacement, belum ada apa-apa sesaran lagi. Okay, let's see the first example. Okay, a particle moves in a straight line. Its displacement S, m is meter, okay? From a fixed point O at time t seconds is given by S equal to 25t minus 5t square. So, you are given this formula. You dah ada formula untuk displacement tu. So, dia kata dia bergerak fixed point, daripada fixed point O. Now, you need to find the displacement, cari sesaran of the particle at time 2 second and also 8 second. So, you already have the formula, this one. All you need to do is, you are given the second, the t, this is your t, okay? All you need to do is, let me conteng-conteng sedikit. This is your t, yeah? This is your t. So, all you need to do is substitute this t into this formula, the displacement formula. You have this one, right? So, you just need to substitute it into this. So, let's see the solution first before we go to the next question. When t equal to 2, so you just substitute the 2, t equal to 2 into the formula over here. 25 times 2 minus 5 times 2 square. So you get 30. So, previously I said that when you have positive number, means that the particle is moving towards the right hand side. Kan? Dia bergerak ke kanan kamu. Okay, so now you have 30 meter. Okay, 30 meter, yang mana jawapan dia adalah positif. So, kalau positif, meaning 30 meter, hence the particle is at 30 meter to the right of O at the time 2 second. Maksudnya pada waktu T 2 saat, pada waktu 2 saat, partikel tu sudah berada 30 meter daripada 30 meter ke kanan daripada titik O tadi. Okay. So let's say you have, you have this point O, okay? Point O, so the particle is moving toward this 30 meter. Okay? They're moving to the right hand side. Okay, then what happen when you have your T is 8 second? Bila masa T kamu adalah 8, di mana keberadaan you punya particle tu? Sejauh mana dia dah bergerak, dia punya sesaran, displacement. So just substitute the T equal to add into the same equation, which is this one. Then you get the answer is negative. What does it mean by negative? Over here, you get negative. Okay? Negatif dekat sini. So, maksudnya, the particle is 120 meter to the left. To the left. Pada waktu 8 saat, dia sudah berada di sebelah kanan, sebelah kiri kamu. 120 meter. Kita jangan ambil kira yang negatif tu kalau kita explain ataupun kita tulis. So, because the negative is just a sign that it's moving towards to the left. Dia bergerak ke kiri. Okay? So, this is how you explain the displacement. The particle is 120 meter to the left of O. Okay? Ini adalah 8 saat. Ini adalah 2 saat tadi. Okay. Let's see the question B. When will the particle, number 1, be at 20 meter to the right of O? Second, be at 70 meter to the left of O. And third, pass through point O again. Ada perkataan again di situ. Okay, so dekat sini yang B ni soalan dia terbalik sikit dengan soalan A. Kalau yang soalan A, you are given time. Okay, you are given T. But now you are given the sesaran, the S. This is all the S. You are given the S now. So what you need to do is you need to substitute the S into this equation. So previously you don't know the S, right? But now you already know the S. What we need to find is the T. When will. Dia kata when will, meaning you're going to find T. What is your T? Okay. What is your T? So, when the particle is 20 meter to the right. To the right, ya, maksud dia. So, your S equal to 20. You ganti masuklah dalam ni. So, tulis semula. 25T minus 5T square equal to 20. Daripada yang ini, Okay, let me erase. Okay, yang ini adalah yang ini. Okay, dia macam ular sudah. Okay, so what you need to do is you going to perform a quadratic equation. Okay, you need to solve this quadratic equation. Dia macam persamaan kuadratik. So you will find out that there are 2t. Ada 2t dekat situ. T equal to 1 or t equal to 4. So bermaksud pada sesaran tu you akan dapat displacement equal to 20 bila t equal to 1 atau t equal to 4. You have two answers. It's okay. You can have two answers. Okay, then the second one, dia kata bila pula this particle berada pada 70 meter ke kiri O. So kalau ke kiri, to the left, meaning you need to put a negative sign over here, kan? Ada negative sign sebab kiri. To the left, ada kiri. So, ganti masuklah dia ke dalam sini macam kamu buat yang tadi. So, then, when you solve for the quadratic equation, you get the answer t equal to -2 or t equal to 7. But, for this case, we cannot accept t equal to -2 sebab masa t time is always positive. Okay, it cannot be negative. Mana ada kita cakap masa negatif 2 saat? Tidak ada kan? So, these two is not accepted. So, the only answer is t equal to 7. Okay? So, I hope you are clear with this very basic example. When you are given formula about the displacement and also you are given the time and the displacement as well, you just need to plug in the value, okay? Okay, and the third one, dia tanya pula soalan yang ketiga. Pass through point O again. Okay, this is quite different from the previous two examples. Yang ni special sikit sebab dia kata dia lalu balik point O tu. Pass through the point O again. Maksudnya dia dah bergerak and then dia patah semula. Dia patah semula. Okay, so when the particle passes through O again, the S equal to 0. S equal to 0. Kenapa kat? Okay, nanti kita akan explain why is it the S equal to 0. Okay, then you just substitute the value into the formula given just now. Then you solve for the quadratic equation, you get t equal to 0 or t equal to 5. Ada dua jawapan juga. But t equal to 0 is not accepted. We only accept this one, t equal to 5. Why is it so? Kenapa kita tidak boleh terima t equal to 0? Because of the word again, dia kata, in the equation. T equal to 0 is the beginning of the motion. Kalau kita ambil jawapan dia t equal to 0, t equal to 0 tu maksudnya yang mula-mula, masa dia masih awal-awal, okay, dia dalam keadaan static, is the beginning of the motion and not the time after the particle has started moving, okay. So that's why we cannot accept t equal to 0. T equal to 0 tu masa dia masih mula-mula pegun, dia static. We can only accept t equal to 5 selepas beberapa second, selepas 5 second, then only the particle moving, okay. I hope you are clear with that. Okay, now we move on to example 2. The displacement S in meter of a particle that moves in a straight line is given by this. Okay, you have another formula given, this one. Such that t is the time in second after the particle has passes through a fixed point O. Find the range of values of t when the particle is at the right hand side of O and B the left hand side of O. Okay, so sama. Lebih kurang dia punya soalan macam yang tadi. You are given as the formula for the displacement. Okay, the formula for the displacement. But now you need to find the range. Need to find the range of values. Kalau tadi you just need to find value saja, nilai. Sekarang kena cari range dia. Range meaning ada dari mana sampai ke mana, ada interval dia lah kan. So dia kata bila find the range of values of t, range of values of t. Start dari berapa second until berapa second yang kita kena cari. So yang pertama ni dia dah bagi hints, dia kata the right hand side of O. Okay, so when the particle is at the right hand side of O, maksud dia punya displacement must be positive, should be positive. Okay, that's why you get greater than 0. So kita buatlah yang ini kan, inequalities. If you have learned about inequalities before, so it should be no problem. Okay, so you have quadratic and then you factorize it into this one. So you get 1t is equal to t equal to 3, and the other one is t equal to 6. Alright? So you have 2t. Satu sebelah sini 3, satu lagi sebelah sini 6. Okay? So kita boleh kata, hence the range of values of t when the particle is at the right hand side of O is from t yang mana? Kita ambil yang atas. Kita ambil yang atas. Kenapa jawapan dia bukan yang tengah ni? Sebab because of this sign. This sign is greater than. So kalau greater than, you ambil yang sebelah atas. Okay, maksud sebelah atas tu yang sebelah sini. Yang belah sini. Okay. Jangan ambil yang belah sini pula. Ini maksudnya belah bawah kan? Ambil yang sebelah sini. So the answer will be t greater than 0, less than 3. Okay. Maksudnya dari sini sampai sinilah graf kamu. Satu lagi t greater than 6. T greater than 6. This is t greater than 6. This one is t daripada t daripada 0 until 3. Kenapa 0? Sebab kenapa bukan negatif atau negatif infinity kan? Sebab time dia start with 0. Paling kecil is 0. Okay? Okay, remember how do I find the answer is up here, not inside in here, is because of this greater sign. Dia lebih besar. So, lebih besar meaning you ambil yang dekat atas. Tapi bukan ambil yang dekat tengah ni. Ambil yang dekat luar ni. Okay? Okay, for B, dia kata left hand side. Left hand side. So, what happen when you left hand side? Left hand side meaning you will have ni. Sign dia adalah less than negative. Should be negative. The answer will be negative. Left hand side. So, kalau less than, bila you factorize, 1 dapat 3, 1 dapat 6 kan? So, bila you less than, maksudnya yang lebih kecil. Yang lebih kecil, maksudnya you ambil yang sign. Ini kan positif. Dekat atas ni positif. Dekat bawah ni is negative. So, because of this is negative sign, you ambil lah yang dekat bawah ni. Macam tu. Okay. So, the answer is this one. While this one, the answer is this. Ada dua. T or T equal to greater than 6. So, that's it for the second question. Okay, let's see the third example. A particle moves in a straight line. Okay, particle tu bergerak pada satu garis lurus. Its displacement in meter from a fixed point O at time t second is given by this. So again, you are given a formula for your S, for your displacement. Find the total distance travel. Okay, so sekarang ada soalan pattern yang baru pula. Total distance travel by the particle in the first 6 second. And the second one, the distance. Ini distance sahaja. Tadi tu ada total distance. Ini ada distance saja. During the 7 second. Okay. Okay, so let's see the solution. Prepare an S to T table as shown below. So, kita buatlah table S dengan T. Okay. Kenapa kita buat macam ni? Supaya senang kita mau plug in the value. Okay. So, first kita cakap dia ada first 6 second. So, the time will start from 0, 1, 2, 3, 4, 5 until 6. First 6 second. Okay, then the second row will be the S. So S ni you ganti masuk formula yang ini. You ganti masuk formula yang ini ke dalam this S. So you ganti masuklah. Kalau T equal to 0, you get the answer S equal to 12. T equal to 1, you get the answer equal to 15. T equal to 2, you get the answer equal to 16. So on and so forth lah sampai yang ini. Okay. So based on the above ST table, student can either sketch a motion diagram or a displacement time graph. Displacement time graph ni lah. Ataupun motion diagram. Motion diagram ni yang macam ni, yang kita lukis macam ni. This is what we call as motion diagram. Okay, now we need to sketch a motion diagram. Okay, based on the above, dia kata, okay, daripada sinilah kan, dia dah ada. You dah boleh lukis dah based on yang dekat sini. Kalau ni adalah point O, yang asal, point O yang mana T dia equal to 0 kan? Point O ni T dia equal to 0. Yang asal. So after 1 second, you get the answer is blah blah blah. After few second, you get the answer is blah blah blah. Okay, macam ni lah dia punya what we call as the motion diagram. Okay, tengok yang 16 meter ni movement dia bila 2 second. 12 ni bila T equal to 0. Oh, dekat sini T equal to 0. Okay. Okay. Sorry. Okay, based on the above motion diagram, the total distance traveled by the particle in the first 6 second. Sebab kita mau cari dia punya ni. Total distance travel by the particle in the first 6 second. So, total distance adalah 4 plus 16. Okay. 4 plus 16. You have this one and also this one. Okay. So, everything you have over here, 7, 12, 15, 16 ni semuanya adalah yang displacement untuk yang time ni. You just plot dia dekat dalam. So, the answer is 16. Also, 4 plus 16. Which is 20 meter. That is total. Okay, biasanya kalau total ni you ambil yang the longest, 16. This one kan, you plus the 4 meter. The 4 meter is given by this one. From here to here. 12 meter ke 16 meter, you have 12 meter ke 16 meter. Ada 4 meter. Beza dia dekat tengah. So, you just tambah this one and this one. Kenapa saya kata yang ini tambah dengan yang ini? Bukan yang ni tambah ni, tambah ni, tambah ni, tambah ni. Bukan. Sebab you tengok dia punya motion tu. Ke kanan ke kiri ke dia. Kalau yang ke kanan moving, this is ke kanan. To the right. Tengok motion tu. Arah dia ke kanan. This one is ke kanan. So, ke kanan dia 4 meter. Ke kiri dia ni 16 meter. Tengok dia ada sign macam ni kan. Maksud dia move ke kiri. Ini sign dia move ke kanan. Okay. Okay. So, how do I know dia move ke kanan, ke kiri? Semua tu nanti bila you substitute dalam sini, you get the answer either positive or negative lah. Okay, then this just now is motion diagram. Motion diagram, this is displacement. Displacement versus time graph method. So, based on the table yang ni, ini macam kita plot macam biasa lah. Okay, T dekat x-axis, S dekat y-axis. So, you plot lah. Kalau T0, dia punya apa tadi? displacement is 12. Plot dekat sini 12. And then kalau t equal to 2, displacement dia is 16. Plot lah dia macam biasa. Okay. Okay, tu maksud dia yang ni. Tengok sebelah sini, kalau you bagi dua, di sebelah sini 16 meter. Ini kan yang maksimum kan? Dia yang maksimum paling tinggi. So, yang sebelah sini ada 16 meter. Yang sebelah sini pula ada 4 meter. So, kita tambahlah 4 tambah 16. Itu adalah dia punya total. Okay, dia kata dekat sini, based on the displacement graph, the total distance travel is 14 plus 16. 14 pula. 4 plus 16. 4 tu dari yang sebelah sini. Kalau kita tengok, yang pick the highest value, ini kan pembahagi dia lah. So, you tengok sebelah kiri, maksudnya dia ada 4 meter. Sebelah kanan ada 16. Okay. Okay. Dia kata ada note dekat sini. Okay. Please refer to example 8 for an alternative method that is more efficient to find the total distance travel by a particle in the first and second. So, this one, example 8, you may refer to your books, your green book, the Success Additional Mathematics. So, all these examples and all these examples and the graph are taken from the book. Okay, you just refer to the example 8. Okay, next the question is distance traveled by the particle during the 7 second. Distance traveled by the particle during the 7 second. So, ini adalah formula yang kita belajar tadi. 7 second. Kalau the first few second, ada dia punya cara untuk kira. And then the next second, we have this formula, kan? You remember the Sn minus Sn minus 1? This is the formula during the n second. Okay? Ini untuk yang first n second. This one is for n second. Sn minus. So you have Sn minus Sn minus 1, okay? So all you have is this. So carilah Sn, Sn kamu adalah 7. This is your n. So n minus 1 is 6. So kita just ganti masuk the formula into yang S tadi, this one, S, okay? Gantilah T itu adalah 7 berapa? Kalau T adalah 6, what do you get? So you get the answer is negative. However, since this is distance, jarak mesti dalam positif. Jarak always positive value, okay? So because you have modulus sign, you will get 9 meter. The distance is 9 meter. Okay.